Hi, welcome back to Docker presentation series. This is Satyadev. In the last presentation, I talked about operating system virtualization. Now, in this video, in this presentation, I'm going to talk about the comparison between OS virtualization versus hardware virtualization, or containerization versus virtualization, or the other way. I mean, basically. So let's get into the specifics. So let's see the architecture diagram. Let's compare the architecture diagrams. Now you can see, I mean, as I have been telling in the last presentations, so this is the um, hardware virtualization. This is the OS virtualization, right? Now you can clearly see infrastructure kind of same. Host OS, here we have host OS, here we have host OS, here also. Here we have hypervisor in the hardware virtualization. Here we have a container engine. Now from here onwards things would start changing. We have a guest OS here, but there is no guest OS here. You have libraries and apps and kind of same. So basically the main difference between container and virtualization, when you see architecturally, is that they don't have any operating system. OS virtualization, which is nothing but the containerization, doesn't have any special operating system, whereas hardware virtualization has got its own operating system. That is why, even though this is a Windows operating system, you can have Linux. Whereas if it is Windows, you can't have Linux. You cannot have. So that's the pretty much the architectural difference. There are other differences. Let's get into them. Now, what are those differences? Architecture, just now we have seen. Each virtual machine includes a full guest OS, its kernel, libraries, the app, and runs on a hypervisor when it is HW, hardware virtualization. When it is containerization, each container includes only the app and its dependencies and runs on a container engine that shares the host OS, which we just now discussed. File system. In virtualization, I'll just call it as virtualization. This is I will call it as containers. I will call it as VM. I will call it as container. So in VMs are independent, complete file system with guest OS. So it's basically complete machine with its own file system. Everything is different. Whereas in containers, the file system would be like layered, in the sense that you have the base file system. On top of that, you can have a different file system. But it's minimal also. Shares host kernel components. So basically, yeah, it shares the host kernel components. Now processes. Isolated process and managed by the guest OS. So let's say you are running an application in a VM, right? Then the application, and there is another VM, another application is running. So you cannot say these two applications can are like next to each other. You cannot say, because it's two independent processes and two independent computers. Like, only thing is, you have to if you want to they want to communicate, they communicate through protocols, like machine to machine protocols, not even like inter-process within the same computer protocol. So that basically, these are all managed by the guest OS. Whereas isolated process but managed, so they can, whereas we containers, it's not like that. If you are having a process in one container, and so both of them are running under the same process, so at a host level you can see those two processes. Whereas at a host level, when it comes to VMs, you cannot see those processes because they are independently separate machines. So that's pretty much the difference between VMs and containers. Another difference is network. Similar to processes, independent virtual network stack. So every VM has got its own network but whereas when it comes to containers, isolated network shares a host network. So basically, whatever network strategy that is followed in the host OS, the same strategy they follow. So they don't have a special network strategy. So OS parity. So basically, it's not required between VMs and hosts. That means Windows can host Linux, whereas required between containers. So that means Windows cannot host. So basically, how does it work? Whether it is VM or containers, they don't have any special hardware or software or special memory or anything like that. They borrow from the host only. In case of VMs, they borrow and hold it, and it's it's not visible to the it's not to the host OS anymore. Whereas in case of container, it's not like that. The host OS knows, okay, this container is using this piece of the memory, this container, this piece, like that it knows. So I mean, it's more bit vulnerable when it comes to container, because the host OS knows what is there, what processors are running, what networks are using, what is the RAM, everything. Whereas when it comes to VMs, it's not possible, because it's completely allocated. It's like you break the machine RAM into 2-3 pieces and give it to the VM. So that's pretty much it. The host OS can't have any control on them. That's pretty much how they are. More differences are performance. VMs are not bit but low performant. The reason, loading of OS. So OS has to be loaded, right? Already there is a host OS. On top of that, you are loading another OS, which takes some time. And also the memory allocated is not as much as the host OS. So definitely it should be less. So it could take more time to load. Right? So VMs are slow. Whereas OS, they are like native applications. You start it, they just boom, they start immediately, kind of thing. Not exactly, but most of the time, or 99% of the time, they start really fast, because they are lightweight and there is no operating system inside them, right? That's what containers are. So when it comes to security, well, like I said, the VMs are isolated from the host, even though they are there inside the host machine. Host machine, once they are created by the hypervisor, don't have any control on on those machines. So they are like running independently, of course, independently. So when it comes to security, they are highly secure. Even if the host machine is like vulnerable, it may not be the VM may not be vulnerable. Whereas when it comes to containers, they are not that much strong when it comes to security, because it is sharing a kernel, so there is some risk involved. So that's pretty much what the security aspect talks about. Startup time, like I said, VMs are slow to start, whereas containers are faster to start. Portability, well, you have a VM in one computer, you want to move that VM to another computer, you can do that. But they are OS specific. For example, you have base is Windows and you have a Linux operating system. You want to move this VM to another Linux machine, not possible, because the core OS is Windows, right? So you have to build a new VM on a Linux only. Then only it can move to a different Linux version. Whereas containers are not like that. You build a container Windows machine, you can almost take that to a Linux machine and run. Again, how do you take containers? We will discuss when we discuss about building containers and all these things. But predominantly, when it comes to portability, VMs are not that portable, whereas containers are, yes, they are highly portable. Use cases. Now, where to use VMs and where to use containers? This is basically use cases. When it comes to huge applications, legacy apps, which could work on different voices, size, security needs, then we use for VM. Underneath it, why do we need VMs? Basically, if you don't have VMs, what happens? If you don't have VMs, the thing is, you have to have different machines. Like you have several machines. So, for example, you have a application where you want to do several kinds of testing. One is like performance testing, another set is like regression testing. So different sets of testing. Now one option is like you have separate machines for performance load, this machine. For regular backward compatibility tests, you use this machine. You could use that. Another option is VMs. You have one machine. In that machine, you create a virtual machine for performance testing. So it is easier, right? It is easier to work with one machine rather than with multiple machines, right? So you need multiple keyboards, multiple mouses, and all that stuff. You have to move across. Whereas with VMs, you just sit on one computer. You can just, okay, not this one. select the next computer, like, within the same thing, right? That's easier. So that makes the life of a tester or a developer easy when it comes to using a VMs. When it comes to containers, normally containers are used for microservices, and yes, in DevOps they play a big role. And when it comes to CI/CD, DevOps and all these aspects, containers are very popular. Examples of hardware virtualization. So virtual machine, like they are like hypervisors. Basically, Hyper-V is a company where actually they provide Hyper-V as a hypervisor. VMware is a company, they provide VMware hypervisor, VirtualBox, etc. There are so many are there. Popular are these three, and these can be used to running Ubuntu, Windows VMs, etc., etc. Now, OS virtualization, there are two popular products. One is Docker, another is Podman. So basically, how do we run? You run for Nginx or Python or MSQL. So you have one target application. Normally, Docker is a container basically. Docker is it's like SOAP is the SOAP is the actual product name. Maybe Synthol is the brand name, right? Similar to that, container is the product and Docker is the brand. So that's pretty much what it is, right? So Docker is actually a container. So Docker, basically the way it works is it holds the most one kind of application. It doesn't have multiple applications. One Docker, one application, one Docker. That's how it is. Whereas virtual machines are not like that. Virtual machine container application could have multiple stuff. Like mostly it is operating system related stuff, like like we discussed earlier. So I think that's pretty much about the differences between hardware virtualization versus operating system virtualization. Thank you for watching this video. We'll meet you in the next video.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.